Hello everyone. Welcome to the training course on nature-based solutions for disaster and climate resilience. This is the session 2, Nature-based solutions concepts. The session agenda is 1. Definition, 2. Economy systems, 3. Types of NBS, 4. Benefits, 5. Challenges. Nature-based solutions are, nature-based solutions, NBS, leverages nature and the power of healthy ecosystems to protect people, optimize infrastructure, and safeguard a stable and biodiverse future. IUCN. Nature-based solutions are actions to protect, sustainably manage, or restore natural ecosystems that address environmental, social, economic, and gender-related challenges while simultaneously providing human well-being and biodiversity benefits. ISOMOD. Nature-based solutions, NBS, are actions to protect, conserve, restore, sustainably use, and manage natural or modified ecosystems. They address social, economic, and environmental challenges while providing human well-being, ecosystem services, resilience, and biodiversity benefits. WWF 2022. NBS addresses societal challenges by protecting, sustainably managing, and restoring natural and modified ecosystems, delivering benefits for both people and the environment. They play a vital role in addressing key global issues such as climate change, disaster risk reduction, food and water security, biodiversity loss, and human health, making them essential for sustainable development. NBS offer a multitude of benefits across environmental, social, and economic domains. They involve using natural processes and ecosystems to address various societal challenges, such as climate change, disaster risk, water security, and urban sustainability. Nature-based solutions, NBS, are pivotal in both preserving and rejuvenating biodiversity. By safeguarding and rehabilitating natural habitats, they sustain a broad spectrum of flora and fauna, thus enriching and maintaining the diversity of ecosystems. In the battle against climate change, NBS are indispensable. They mitigate carbon dioxide through organic processes such as photosynthesis in forests and natural carbon storage in soil. Additionally, they offer practical adaptive strategies, exemplified by mangroves, that lessen storm surges severity. Ecosystems like wetlands and forests play a crucial role in water cycle regulation. They are capable of filtering and cleansing water, diminishing flood risks, and preserving water flow, all essential for the reliability and quality of water supplies. NBS bolster resilience against disasters. Restoring floodplains and conserving coastal ecosystems, for example, serve as natural defenses against flooding and storm surges, mitigating their impact on communities. Offering sustainable and often more cost-effective alternatives to conventional infrastructure, NBS creates sustainable economic ventures in areas like ecotourism, responsible fishing, and forestry. Interaction with natural environments is associated with numerous health advantages, such as stress reduction, enhanced mental health, and overall physical well-being. Urban green areas are especially vital for leisure and relaxation. Numerous NBS initiatives engage and benefit local communities. They improve livelihoods through sustainable resource utilization and foster community-led environmental stewardship. In urban settings, NBS, including green roofs, parks, and living walls, counteract urban heat islands, augment air quality, and provide spaces for recreation. NBS are effective in averting soil erosion and degradation. Techniques such as agroforestry and sustainable land management are key to preserving or boosting soil fertility. Natural areas and practices hold considerable cultural and educational significance, offering insights into environmental preservation and sustainability. Urban and rural greenery, such as trees and plants, are essential in purifying air by filtering pollutants, thus enhancing air quality. NBS also support pollinators by preserving their habitats, a critical factor for agriculture and the preservation of biodiversity. Nature-based solutions present a comprehensive strategy for tackling various societal challenges, seamlessly integrating human well-being with environmental stewardship. They embody a synergy of ecological, social, and economic factors, paving the way towards communities that are both more resilient and sustainable. Infrastructure and NBS represent two distinct but increasingly complementary approaches to addressing societal and environmental challenges. Traditionally, infrastructure has relied on man-made, engineered solutions, while nature-based solutions utilize natural processes and ecosystems. However, there's a growing recognition of the benefits of integrating these approaches. Before we look in more detail at how infrastructure and NBS can work together, here are some commonly used terminologies on the different types of infrastructure. Incorporating nature-based solutions, NBS, into infrastructure projects enhances resilience to climate change and natural disasters. Utilizing natural features like wetlands and floodplains in conjunction with conventional structures such as levees and seawalls can result in more effective and robust flood defense systems. Fusing NBS with urban infrastructure can pave the way for more sustainable and healthier cities. Establishing urban forests, green belts, and parks not only purifies the air but also provides vital recreational areas, all while complementing essential urban systems like transportation networks. Merging NBS like constructed wetlands and riparian buffers with standard water treatment and management systems augments water quality, fosters sustainable water management, and aids in replenishing local water sources. Employing NBS in tandem with traditional infrastructure solutions can prove more economical in the long run. Natural systems often demand less upkeep and display greater resilience to environmental shifts, leading to reduced ongoing maintenance costs. Integrating NBS within infrastructure initiatives is key to safeguarding biodiversity and sustaining vital ecosystem services, including pollination, carbon capture, and soil erosion prevention. The inclusion of green spaces and natural components in urban infrastructure design significantly boosts residents' mental and physical health by offering recreational spaces and diminishing pollution. Incorporating NBS with traditional infrastructure plays a substantial role in mitigating climate change. For example, urban tree planting not only cools urban areas but also helps in carbon sequestration. Infrastructure designs that encompass NBS typically exhibit greater adaptability to environmental changes. Natural coastal buffers, for instance, are more equipped to adjust to rising sea levels compared to inflexible seawalls. Embedding natural elements within infrastructure enhances the aesthetic and cultural appeal of built environments, creating spaces that resonate with local identity and heritage. Ultimately, the fusion of infrastructure and nature-based solutions provides a comprehensive developmental approach. It marries the robustness and dependability of traditional infrastructure with the sustainability and resilience of natural systems. This combination is essential in forging resilient, sustainable, and livable communities amidst global environmental and societal challenges. Another important concept is low-impact development. Low-impact development, LID, is an innovative approach to managing stormwater and urban development with the goal of minimizing environmental impacts. It focuses on managing rainfall at the source using decentralized microscale control measures. This approach seeks to mimic and maintain the natural water cycle, thereby reducing the impact of development on the environment. Low-impact development, LID, and nature-based solutions, NBS, are both innovative strategies in environmental management and urban planning that emphasize sustainable and naturalistic approaches to development. While they share common goals and methods, they each have distinct focuses and applications. Low-impact development, LID, primarily aims to minimize the impact of urbanization on the environment, particularly concerning water systems. Focuses on managing stormwater as close to its source as possible, often through the integration of design techniques that infiltrate, store, evaporate, and detain runoff. seeks to mimic or maintain pre-development hydrology through decentralized structures. Techniques include green roofs, permeable pavements, rain barrels, bioretention cells, and vegetated swales. Nature-based solutions, NBS. Broader concept that encompasses the use of natural processes to address various environmental, social, and economic challenges. Involves restoring or protecting ecosystems and biodiversity, and the services they provide, across rural and urban settings. Can include LID methods but also extends to larger-scale initiatives like reforestation, wetland restoration, and urban green space conservation. NBS are used for climate mitigation and adaptation, disaster risk reduction, water management, and creating sustainable urban environments. Both LID and NBS represent a shift away from conventional engineered or gray infrastructure towards more holistic, sustainable practices that work in harmony with nature. They prioritize ecosystem services and biodiversity as integral to human well-being and urban sustainability. By incorporating these practices into development planning, cities and communities can improve resilience to environmental changes, enhance quality of life, and ensure long-term environmental health. Nature-based infrastructure refers to a strategic approach that utilizes natural systems and processes to deliver services and solutions to various societal challenges. These include environmental management, climate change adaptation and mitigation, water and air quality improvement, and enhancing urban resilience. The concept is grounded in the philosophy that nature can function as a form of infrastructure offering a wide array of benefits. Here's what characterizes nature-based infrastructure. Nature-based infrastructure is not only about creating new natural spaces but also about protecting and enhancing existing ones. This approach is central to sustainable development, as it seeks to harmonize ecological integrity with human needs, leading to resilient and adaptable systems for current and future generations. You can see the relationship between infrastructure, nature-based infrastructure, and nature-based solutions in the diagram in the slide. Ecosystems are communities of living organisms in conjunction with the non-living components of their environment, interacting as a system. These components are linked together through nutrient cycles and energy flows. Ecosystems can be of any size but usually encompass specific, limited spaces, although it is sometimes difficult to see where one ecosystem ends and another begins. Key characteristics of ecosystems include structure. This includes the living, plants, animals, and microorganisms, and non-living components, like air, water, and mineral soil, that make up the environment. Function. Ecosystems are characterized by ecological processes such as photosynthesis, respiration, decomposition, and nutrient cycling. Complex interactions. Within an ecosystem, species interact with each other and their physical environment. These interactions can be competitive, predatory, symbiotic, or mutualistic. Diversity. Biodiversity within ecosystems includes species, genetic, and ecosystem diversity. Dynamic nature. Ecosystems are dynamic entities. They are subject to periodic disturbances and are in the process of recovering from some past disturbance. Self-regulation. Ecosystems have the ability to self-regulate through feedback loops. Ecosystems are classified into various types, often based on their nature or predominant environment, such as forest ecosystems, grassland ecosystems, desert ecosystems, aquatic ecosystems, including marine and freshwater ecosystems, and man-made ecosystems like agricultural ecosystems, agroecosystems. Each type of ecosystem has distinct characteristics and species adapted to its specific environment. The health and functionality of ecosystems are critical for the provision of ecosystem services upon which all life, including human life, depends. Ecosystem services are the many and varied benefits that ecosystems provide to humans. These services are essential for the survival and well-being of humanity and are generally categorized into four main types. Ecosystem services are integral to human well-being, and their degradation can have significant adverse effects on human health and prosperity. The concept is crucial in environmental and ecological economics, conservation and sustainability strategies, land management, and policy making, as it provides a framework to help recognize the value of nature's contributions to humanity. From this picture, what ecosystem services are being provided here? If you mentioned food provision, fish and other freshwater organisms, regulation, flood control, support, nutrient cycling, and recreation, then you are on the right track. Ecosystem services can be classified into 4 types of services. Provisioning services. These products are obtained from ecosystems, such as food, fresh water, wood and fiber, genetic resources, and medicinal resources. They are the most tangible benefits that humans derive directly from ecosystems. Regulating services. These services include the benefits obtained from the regulation of ecosystem processes, such as climate regulation, disease control, water purification, pollination, carbon storage and sequestration, and flood mitigation. Regulating services help to maintain the balance of the environment that supports life. Cultural services. Ecosystems provide cultural or non-material benefits that people obtain through recreation, tourism, spiritual enrichment, cognitive development, reflection, and aesthetic experiences. This includes the inspiration we derive from nature, the spiritual significance of certain landscapes, and the community value of parks. Supporting services. These services are necessary for the production of all other ecosystem services, including soil formation, photosynthesis, nutrient cycling, water cycling, and the provision of habitat. They underpin the functioning of ecosystems and the production of the aforementioned services by maintaining biodiversity and the production of ecosystem goods. The loss of ecosystem services is a significant risk to the future prosperity and stability of human society. Recognizing their value is crucial for sustainable development and for devising strategies to conserve and restore natural habitats and the services they provide. The value of ecosystem services is immense and multifaceted, encompassing economic, environmental, social, and cultural dimensions. Quantifying this value can be challenging but essential for informed decision-making and sustainable resource management. Here are various aspects of the value that ecosystem services provide. Economic value. Ecosystem services contribute directly and indirectly to the economy. Provisioning services such as food, water, timber, and fiber are the basis of industries like agriculture, fisheries, and forestry. Regulating pollination and water purification services are critical for sustaining these industries. By estimating the cost of replacing these services with man-made alternatives, we can begin to quantify their economic value. Social value. Ecosystem services are crucial for social welfare and community development. They support livelihoods, especially for rural and indigenous communities that directly rely on natural resources. Cultural services provide a sense of place and identity, which is important for social cohesion and mental health. Environmental value. Ecosystems maintain biodiversity and genetic diversity, which are vital for the resilience of the environment to adapt to changes and disturbances. They help regulate climate, air quality, and disease vectors, which are essential for the stability and sustainability of the planet's life support systems. Cultural value. Natural landscapes are deeply interwoven with human culture and history. They serve as inspiration for art, folklore, and spiritual experiences and are integral to education and recreation. The cultural significance of ecosystems is invaluable and often irreplaceable. Health value. By providing clean air and water, safe food, and opportunities for recreation and stress relief, ecosystem services have a profound impact on physical and mental health. Intrinsic value. Beyond the utilitarian benefits to humans, ecosystems have intrinsic value. Many argue that nature has value in its own right, independent of human needs or perceptions. Regulatory value. Ecosystems contribute regulatory benefits that help mitigate natural disasters, such as flood control by wetlands or storm surge protection by coral reefs. The cost savings for disaster relief and infrastructure repair can be considerable. Support services value. The fundamental processes like soil formation, nutrient cycling, and primary production are the building blocks upon which other services depend. While these services do not have a direct market value, their contribution is essential for the provision of all other ecosystem services. These values can be captured through monetary, quantitative, or qualitative approach to demonstrate the importance of ecosystem services. Given ecosystem services' vast array of benefits, their degradation or loss can have significant economic and societal costs. Recognizing and integrating the value of ecosystem services into policymaking, planning, and development is crucial for the sustainable use of our natural resources and the well-being of current and future generations. Principles of NBS including nature-inspired, leverage natural processes and ecosystems. Cost-effective, provide high returns on investment compared to engineered solutions. Multifunctional, deliver multiple benefits, e.g., disaster risk reduction, carbon sequestration. Resilience building, enhance ecosystem and community resilience to shocks. Key aspects of NBS include conservation, restoration, and sustainable management. This involves protecting existing ecosystems, restoring degraded ones, and managing both natural and modified ecosystems to balance people's and nature's needs. Ecosystem services. NBS relies on and enhances ecosystem services, such as clean water, air, fertile soil, and pollination. Biodiversity. They contribute to biodiversity conservation, which is fundamental for ecosystem resilience and the continued provision of ecosystem services. Climate adaptation and mitigation. NBS can be instrumental in adapting to climate impacts, like absorbing excess flood water or providing shade in urban areas, and mitigating climate change, through carbon sequestration in forests and wetlands. Disaster risk reduction. They can help reduce the risk and impacts of disasters, such as using wetlands to buffer storm surges or mangrove restoration to protect coastlines from tsunamis. Social and economic benefits. NBS often provides livelihood opportunities and economic benefits, promoting sustainable development in local communities. Cost-effectiveness and multifunctionality. NBS can be more cost-effective than traditional engineered solutions, often delivering multiple benefits simultaneously. According to UNOLAB, NBS has been categorized into 8 types each with specific examples and applications. This categorization helps cities and practitioners to select suitable NBS types based on local needs like heat mitigation, stormwater management, biodiversity enhancement, and public space improvement. Here are the types of NBS. Green roofs, the vegetated roof systems designed to manage rainwater and improve building insulation. Green walls, it is a vertical greening systems for cooling, insulation, and air purification. Permeable surfaces, surfaces that allow water infiltration to reduce runoff and promote groundwater recharge. Rain gardens and bioswales, shallow vegetated basins or channels for stormwater collection and filtration. Urban forests and trees, trees and forested areas in urban environments for shade, cooling, and air quality improvement. Constructed wetlands, engineered wetland systems mimicking natural wetlands for water treatment. Blue-green infrastructure, BGI integrated water management and green space systems for flood control and urban resilience. Parks and green spaces, uncovering and restoring buried or culvert water bodies to their natural state. Daylighting rivers/streams, uncovering and restoring buried or culvert water bodies to their natural state. Retention and detention systems, systems that hold stormwater temporarily to reduce peak flows and improve quality. Green corridors and connectivity, continuous green networks enabling species movement and ecosystem services. Within the green infrastructure spectrum, there are different approaches. NBS is an umbrella concept of ecosystem-based approaches to address societal challenges. And these approaches include: 1. Low-impact development relevant for urban planning. 2. Restorative approaches in integrated coastal zone management. 3. Sustainable land management approaches. 4. Integrated water resource management. 5. Integrated fire management. This session will focus on low-impact development, integrated coastal zone management, and sustainable land management. Most importantly, when we implement NBS, we have to keep in mind the 8 principles as advocated by IUCN. 1. NBS embraces nature conservation norms and principles. However, they note that while NBS embraces nature conservation, not all conservation actions necessarily qualify as an NBS. 2. NBS can be implemented alone or in an integrated manner with other solutions to societal challenges, e.g., technological and engineering solutions. 3. NBS is determined by site-specific natural and cultural contexts that include traditional, local, and scientific knowledge. 4. NBS produces societal benefits in a fair and equitable way in a manner that promotes transparency and broad participation. 5. NBS maintain biological and cultural diversity and the ability of ecosystems to evolve over time. 6. NBS are applied at a landscape scale, taken to mean large spatial areas, such as watersheds or large forests, which usually combine several ecosystems, agricultural, inland waters, coastal, forest, etc., and which might in some cases be transboundary. 7. NBS recognizes and addresses the trade-offs between the production of a few immediate economic benefits for development and future options for the production of the full range of ecosystem services. 8. NBS are an integral part of the overall design of policies and measures or actions to address a specific challenge, with a primary goal of understanding how some of these solutions enhance the adaptive capacities of the system. Nature-based solutions, NBS, offer a wide range of environmental, social, and economic benefits by leveraging natural processes to address societal challenges. These benefits are well documented by IUCN, UN agencies, and various NBS initiatives such as UNOLAB. Such benefits make NBS a critical pathway toward achieving global agendas such as the SDGs, the Paris Agreement, and the Sendai Framework for Disaster Risk Reduction. Key benefits of nature-based solutions. For environmental, it can enhances biodiversity and ecosystem health, improves air and water quality, regulates climate, carbon sequestration, urban cooling, restores degraded land and water systems. For climate resilience, it can reduces flood and drought risks through natural water regulation, supports climate change adaptation, buffers against extreme weather events. For social, it can provides recreational and cultural spaces, improves mental and physical health, enhances urban livability and aesthetics, empowers local communities through participation. For economic, it can creates green jobs and stimulates sustainable industries, increases property values near green spaces, reduces costs of gray infrastructure, e.g., stormwater systems, offers long-term cost-effectiveness compared to conventional solutions. For governance, it can promotes inclusive, participatory planning, encourages cross-sector collaboration, supports integrated policy and urban planning. Nature-based solutions, NBS, while offering many benefits, also face a range of challenges in design, implementation, financing, and long-term sustainability. These challenges must be carefully considered to ensure that NBS are effective, equitable, and resilient. Some of the challenges are highlighted that categorized are as follow. For policy and governance, its challenges are lack of enabling policies or integration into national/local plans, overlapping mandates and fragmented institutional frameworks. Weak enforcement of environmental regulations. For financing, its challenges are limited or short-term funding mechanisms, difficulty monetizing long-term ecosystem services, unclear return on investment compared to gray infrastructure. For technical and design, its challenges are lack of standardized metrics for effectiveness and co-benefits, complexity in designing at a landscape scale, need for context-specific scientific and traditional knowledge. For monitoring and evaluation, its challenges are inadequate systems to track performance and long-term outcomes, difficulty in quantifying ecosystem service benefits or trade-offs. For community and equity, its challenges are risk of exclusion of marginalized groups or indigenous peoples, unequal distribution of benefits, limited community ownership or engagement in planning and maintenance. For scalability and replication, its challenges are NBS often remain as pilot projects, limited capacity and awareness among planners and decision-makers, challenges in mainstreaming across sectors and scales. For environmental risks, its challenges are poorly designed or placed NBS may cause ecological harm or unintended consequences. Climate variability may reduce effectiveness over time. Addressing these challenges will require strong governance, inclusive planning, long-term investment, and robust monitoring frameworks, often guided by the IUCN Global Standard for NBS. Now we have reached the end of session 2. Please feel free to go back to any part of the session to get a better understanding. When you are ready, please proceed to the quiz section as the final activity to complete the session.